What's up, people? Welcome to the session. I hope all of you guys are doing good. Welcome. How are you, people? All awesome. Very good afternoon. Can you guys all hear me and see me clearly? Can you guys please let me know in the chat box if everything's all right, so that I can go with full confidence. Otherwise, I'll be just miming, and you guys will be looking at my beautiful face. That's what's gonna happen. Hi, Simranji. What's up? Welcome, people. Can you guys all hear me? All good? Can I get a thumbs up if everything is all right? Please, people, give me a quick thumbs up. Let me just switch back. All right, give me a quick thumbs up if everything's all right. Can I get a thumbs up? Thanks a lot. You guys can hear me clearly. All good? Awesome, people. Thank you. Hello. What's up? Ki hal chal, people? Ki hal chal? All good? Welcome, guys. I hope you guys are awesome. Today, we're going to be doing the continuation of what we did in the last session. So if you guys remember, in the last session we had done, that was yesterday basically, we had done basically 10 more, CBSE 10 most important questions for people who are appearing for your boards in the next couple of days. So this is going to be part 2 of that. Once again, we're going to have a mix of all both the chapters from electricity as well as magnetic effects of electric current. We'll try to solve some questions. So people, can I get a oh yeah in the chat box? And for all those who are here, welcome. Well, where is that? Yes. What's up? Welcome, people. Welcome. All good? All right. Oh, is it? Arey, it's okay. Satyam ji, की बात डरने का की बात English ही तो है. Chill करो और English लिखो. That's all. It's not that hard. Come on. Why are you guys so scared of English? I literally used to sleep before my English paper because it's probably the most easiest ones. Yeah, if Amit sir hears this, he's going to kill me. But still, it's still probably one of the most easiest paper there is. No, because it's only stories. There is nothing to it. No. Anyways, hi Antara. Hi. Welcome, guys. So people, are you guys ready for these questions? Yeah. Can I get a Josh wala oh yeah in the chat box? Full Josh. We'll start off the session with a dole. No, we'll start with a drum roll. Yes. Where is the drum rolls? Yes. Let's go, people. Let's go. Hi, Utkasha. Thank you. Snoop Uncle. Who's Snoop Uncle? I'm young and wild and free. All right. So let's begin, guys. Now, all those who are on the YT platform right now, YouTube platform right now, if you guys want to experience the joyousness and all these beautiful GIFs and quizzes on the Vedantu's platform, all you have to do is go to the description of this video. So all you have to do is this, people. I'll just guide you how to do that, people. So all you have to do is go to the description of this video. First of all, hit the like button, subscribe to the channel. It helps us out a lot. So once that is done, what you have to do is basically, people, hit the thumbs up and subscribe. So what you have to do is go to the first link that you see on the top. That is basically this one right here. Let me just so you can see my face as well. So all you have to do is click on this link that you see on the top. This link would direct you towards Vedantu's website, where you can actually take part in the quizzes and take part in the quiz of today's session. So hope to see you guys over there in the session, so that you can actually interact and also experience this beautiful platform, right? So with that said, let's move on to the topics. So without wasting much of your time, we have once again divided the questions into 2 markers, 3 markers, and then the 4 markers. So we'll start with the 2 markers. As always, we'll start with the easy questions, trial balls. Then we'll go on to the actual real balls, and it's going to be duck out by the 4th markers. All right. So shall we begin, people? Yeah. All right. Sai, it's easy to you have to just click on that link. That's all. Yes, Utkarsha ji, पहचान लिया. हमारा brain बहुत sharp है. All right. So let's get started, guys. The first 2 marker on your screen. Here it is. Very simple, very straightforward, EG-PG question. The question is, define 1 volt, express it in terms of the SI unit of work and charge, and calculate the amount of energy consumed in carrying a charge of 1 coulomb through a battery of 3 volts. Define 1 volt in terms of the SI unit of work and charge. That is one question. That is one part of the question which would give you 1 mark. The rest of the question is basically you have to calculate the energy consumed if you were to carry a charge of 1 coulomb through a battery of 3 volt. All right, very simple question. Go ahead and put it down in the chat box. I know, Anji. हम तो माहिर निकले हम तो अभी ज़्यादा ही बोलने का enough. Okay, potential difference is said to be 1 volt when 1 joule of work is done. Oh, absolutely wonderful one. Then absolutely, super awesome. Anyone else? Any other definition that you can think of? Think of people. 1 joule of work is done to move 1 coulomb of charge is called 1 volt. Absolutely fantastic. That's super awesome. Share, wah bhai wah. Absolutely. So what is 1 volt is nothing but 1 volt is said to be the potential difference when 1 joule of work is done to move a charge of 1 coulomb. To move a charge of 1 coulomb. To move a charge of 1 coulomb. That is what is defined as 1 volt. Now again, here they have specifically asked you to define in terms of work and charge. So this is the right definition for that. Okay, now moving on to the second part of the question, which is a very simple, straightforward numerical, which is nothing but calculate the energy consumed in carrying a charge of 1 coulomb through a battery of 3 volt. Very simple question. Absolutely, super awesome. I mean, we should have a round of applause for this one. That is simply amazing. Where is the round of applause there? Yes! Let's go! Congratulations, my boys and girls. Absolutely fantastic. Absolutely correct. So basically, we know that, we know that, what is that? Work done or potential difference is equal to work done by charge. Or, we can also write this as work done is equal to V into Q. All you have to do is substitute the values over here. So it's 3 into 1, which is equal to what? 3 joules. Simple. All right. That's how you do it with the flares. Getting it? All right. Second question. Let's move on to the second question, people. Again, a 2 marker. You have two parts for this question. Once again, the question is, how is the strength of magnetic field near a straight current carrying conductor? The first sub question is related to the strength of the current in the conductor. And the second one is affected by changing the direction of flow of current in the conductor. Let's go people. Very simple question again. How would the strength of the magnetic field around a straight current carrying conductor differ or be affected by increasing the strength of the current, all right, or in terms of related to the strength of the current? If you're increasing or decreasing it, what would that have, or what sort of impact would that have on the magnetic field as a question? Very simple, guys. Let's go. Absolutely, super awesome. Once again, fantastic job, people. We know that the magnetic field near a straight current carrying conductor is directly proportional to the current. So magnetic field is directly proportional to the current. Greater the current, greater or stronger the magnetic field. Lesser the current, the weaker the magnetic field is going to be. Fantastic. All right, second one. How is it going to be affected if you're changing the direction of flow of current in a straight current carrying conductor? If you were to change the direction of current, what sort of impact will that have on the magnetic field of a straight current carrying conductor? Very simple question again, guys. Go ahead. Exactly. Now, let me ask you one more simple question. What rule would you use here in order to find that direction, people? In order to find that direction of magnetic field? Come on, I know you know this. All the cutie pies. Which one? Fleming's left hand rule, no? Right hand rule. Well done. Awesome, exactly. Maxwell's right hand thumb rule is the one that you're going to use. Fantastic job, people. So here again, once again, if you change the direction of current, as you change the direction of current, the direction of the magnetic field would also change accordingly. All right. So don't worry, guys. You can always download the notes later. All of the notes are right here. That's why I'm not writing much, because you can download the notes from the platform itself and you can use it, refer to it whenever you want. All right. Moving on to the third question. Why and when does a current carrying conductor kept in a magnetic field experience of force? And list the factors on which the direction of this force depends on. Let's start with the first question. Why and when does a current carrying conductor kept in a magnetic field experience force? Very simple question. Let's go, guys. Let's go. Wow, Vandana ji, wow. Alright, Maxwell's right hand thumb rule. Absolutely, Ananya, absolutely. Okay, now to answer this one. Why and when does a current carrying conductor kept in a magnetic field experience force? Let's go, people. Come on. Yeah. Perpendicular to each other. Okay. Alright. Okay, kept perpendicular to each other. So when it's perpendicular, it experiences maximum force. All right. See, the question is, why does a current carrying conductor experience a force? Why does it? Not the question is not how or where do you have to keep the conductor in order to, for it to experience maximum force. The question is, why does it even happen? Like, what is the possible reason for this to happen? That is the question. Perpendicular to the magnetic field? Perpendicular? Nay. Think. Why does this happen? Why does it happen? When is correct. When is absolutely correct. When they are kept perpendicular, absolutely correct. When they are perpendicular to, when the current carrying conductor is placed perpendicular to the magnetic field, yes, it will experience force. But why? Induction of current today, Mama. Okay, see, this is where you need to understand the fact that, guys, see, why does this happen is that in a current carrying conductor, the electrons are basically freely flowing from one end to another, right? The electrons are the ones that is basically flowing from one end to another. When these electrons are flowing and it's kept between a magnetic field, let's say it's kept between a horseshoe magnet, what would happen is that the electrons will experience a force because of the magnetic field. That force experienced by the electrons is what you see as the movement of the conductor. Getting it? It's not the collision, it is not the induced current, it is not any of that. It's because the electrons are experiencing a force. They are experiencing a force because they are kept in a magnetic field, and that is what is leading, or that is what we call as Lorentz force. So you need to mention that, people. All right, that is the why. Why do they experience it? Because the electrons which are moving through the magnetic field will experience a force because of there's a magnetic force experienced by these electrons, and that is what we know, or what we call as our very own Lorentz force. All right. Now, talking about the factors affecting the direction, that is very simple. So put it down in the chat box, people. What are the factors based on which the direction of this force depends on? Let's go, guys. Come on, quickly. Got it? So that is the reason now. Please don't forget that. Direction of force depends on the direction of magnetic field. Exactly. Arey Saiji. BIL. Super. क्या बात है people, क्या बात है? Can we have one more astronaut for doing a great job? Fantastic, guys. Fantastic job. Alright, so for this one, it's actually very simple, very straightforward. Absolutely correct, people. So it is basically the fact that it depends on two factors. One is that it depends on the magnetic field, the direction of the magnetic field. Whatever the direction of the magnetic field, that is one thing that it depends on. And secondly, it also depends on the current, the direction of current as well. So both of these are the deciding factors based on which the direction of Lorentz force also works on. All right, the next question is something that was asked in 2010 and 2012 board exams. The question goes like this. You have two metallic wires of resistance 60 and 30 ohms. How will you connect these wires in order to get an effective resistance of 20 ohms? This is by far one of the most easiest question now. Easiest numerical that you will ever find. You have two wires, one is of 60 ohms, the other is of 30 ohms. You need to connect them such a way that the effective resistance of both of these will be equal to 20 ohms. That's all. What bacha question and all, no? Like from that time, wait, I'll sort this out. Still lagging? One sec, guys. All right. People who are in the platform right now, can you guys all hear me and see me clearly? Can I get a thumbs up for that? All good? Give me yes if everything is all right. No lags, nothing. All good, no? From your end, it's all good, right? Okay, no lags, no? All right, awesome. Now, okay. All right, finally. All right. Thank you for that. Thank you, people. Thank you. Sorry for that. I mean, internet key, internet, my internet. It's not just my internet. It's just that, PBMP, right? Oh, sorry. BBMP. No, that's not BBMP. BESCOM. Yes. So BESCOM likes to play games with me sometimes. BESCOM is basically our, current providers in Bangalore. They like to play games with me sometimes. So whenever, it happens only when I'm taking sessions, all right? Otherwise, it's perfectly fine. Only when I'm taking sessions, no, I don't know. There's some sort of grudge that they take up on me. Like whenever I go live, it happens all the time that at least once, they don't get sleep if they don't, cut the current at that time. It's okay, happens. All right, I manage so much hatred everywhere, but I love you all. All right, sarangiyo. All right, let's move ahead. Too much. All right. Okay, so this question is very simple, guys. All you have to do is connect them in parallel. Once you connect them in parallel, if you want to show me the if I have to show the calculation, it's going to be R equivalent is equal to 1 by 60 plus 1 by 30, which basically is into 2 into 2. So it's going to be 1 plus 2 whole divided by 60, which is equal to 3 by 60. So R is going to be 60 by 3. 3 2s are 6. So it's going to be 20 ohms, which means that you have to connect them in parallel in order to get an effective resistance of 20 ohms. All right. Okay. Moving on to the next question, people. The next is going to be the 3 markers. Congratulations, people, once again for having a fantastic response. 2 markers are done. Now let's move on to the 3 markers. 3 markers again, 3 markers are going to be a little bit more, again, descriptive in nature as always. Please be a little descriptive, but yes, these questions are very important. And all of these questions, again, have been taken from previous year boards. So if you haven't gone through that yet, again, I'm saying that this is a very good opportunity for you guys to go through what type of questions were asked on the boards. All right, here's one more. The 5th question. For the current carrying solenoid, as shown below, draw the magnetic field lines and giving reason, explain that out of the 3 points A, B and C, at which point the field strength is maximum and at which point is it minimum. Fantastic question, because this question was asked in yesterday's session also, and we had a lot of confusion, we had a lot of debate on this one, and I was very interested to know that some of you guys actually went with different answers. So here I'm going to clear all of your confusions. So please go ahead and answer this, people. Where is the magnetic field going to be maximum and a minimum? There are 3 points given, A, B and C. So let's start with minimum. Where is the magnetic field going to be minimum over here around the solenoid? Minimum. Where is it going to be minimum? Let's start with that. Where is it going to be minimum? I should have max, but due respect to NCERT, is it C? Okay, let's see. Minimum, pakka, 100%, absolutely. Fantastic job. Minimum is definitely going to be in the middle, which means it's going to be near B, because outside the solenoid the magnetic field is going to be weaker, and that's same for even a bar magnet as well. So absolutely correct, it is going to be minimum for B. All right, now for maximum, is it point A or is it point C? Okay, what do you guys say? Tell me, what is the majority going to be like? Okay, tell me, all the people who are in the here in the platform, tell me, would you guys go with A or would you guys go with C? And all the people in the chat box on the platform on YouTube, please let me know. A, pakka. B is close, but C is far. Day. All right. Parallel, max is at A. Max is at C after A, and B is at minimum. All right, Sneha. Interesting. A, pakka. 100%. I'll log the answer. All right. The answer in 3, 2, 1 is definitely going to be A. It is going to be maximum inside the solenoid, guys. Inside the solenoid itself, it's going to be maximum. Please remember this. Again, I told you this. I told you this. It is better to ask your class teacher also once, your school teachers also once. But according to physics, according to the laws of physics, according to what we have learned, it's absolutely going to be strongest inside the solenoid rather than the outside. But again, NCERT, CBSE as a whole, sometimes follow different answers. So I'll just tell you one thing, people. Listen carefully. This is very, very important. So listen very carefully. All right. Something that I didn't mention yesterday, but I'm going to mention now. So listen very, very carefully. Please cut this part and send it to your friends. So whoever has confusion in this part, please let them know. All right, I'll tell you what you have to write. If in your exam, I'll give you these 2 scenarios. If in your exam, they've given you a scenario where it's an objective question where they've clearly asked you, where is the magnetic field going to be the strongest between A or B, you can directly go with A. No doubt, A is stronger. All right. If in case it is a subjective question where they have asked you to, give a little bit more explanation on it, what I would suggest you to do is please write that the magnetic field inside the solenoid is going to be the strongest. Why? Because the solenoid is hollow in nature. And inside this hollow cylinder or the hollow structure, the magnetic field is going to be uniform and it's also going to be very, very strong. But the added point is that, also mention this one more point. Let's say that I place a soft iron core inside, or let's say I place an iron nail inside. If I were to place an iron nail inside or an iron core inside, then I can't experience the magnetic field anymore. So at that time, I can say that the magnetic field is stronger near the poles. Getting it? Are you able to understand this? Are you able to understand this? If I place a soft iron core on the inside, or if I were to place an iron nail on the inside, then I can't really see the magnetic field lines. Then I can say that the magnetic field is stronger near the poles because the iron core is also getting magnetized now. Alright? If that is not the case, if it is a hollow cylinder, then you can clearly say that inside the solenoid, the magnetic field is going to be maximum. Got it? Is that clear, people? Is that clear? Now again, I'm telling you, I would suggest you, or I would request you to share this part alone at least to your friends so that they also, don't miss out on this, so that they also can score good marks and don't be confused about all this. All right. So do that. All right. Please do that. All right. So, sir, if it is a bar, if it's a bar magnet, then it's a different thing. No? Because in a bar magnet, obviously, magnetic field near the pole is the strongest. Near the poles would be the strongest. There's no doubt about it. The problem is that we always say that the magnetic field of a solenoid is very similar to that of a bar magnet. And that is where the confusion lies. Because of this one statement, that magnetic field of a solenoid is very similar to a bar magnet, we are also, or most of the school teachers also come to the assumption that the magnetic field near the poles is maximum, but actually it's not. It's actually inside the solenoid. All right. See, that is what. So here, maybe you can say that because it looks like a core. So C could be the answer, but in most cases, then it will not be there. The core might not be present. But in this case, maybe, okay, even I didn't notice that. But yeah, because there is a core, you can say option C is correct. All right, because there's a core. But if there is no core, then you can say that option A is correct. All right. So if you talk about generally a solenoid, it's A. So yesterday's question, whoever asked, so all you have to do is, that is what I'm trying to tell you. If they're asking you that, mention this point also. Mention this point that if there's a soft iron core or an iron nail present inside the solenoid, then the magnetic field is stronger near the poles. Just mention this one line. That way, the teachers will not be able to deduct your marks in any way. All right. Sounds good. All right. C is also correct. Yeah. Got it. All right, clear? So this is the only suggestion I would have for you is that, because again, I don't want you guys to lose marks just because of all these small details, right? Smaller details, but it would actually boost your marks and your confidence a little higher. All right, people, moving on to the sixth question now. Again, a 3-marker. Now here is another easy question, but this particular question was asked apparently in 2012 twice. All right. Maybe there's a small typing error. But yeah, 2013, 14, 15 and 12, back to back, this question was asked. A very, very simple question. So in the chat box right now, put it down, guys. State Joule's law of heating. Let's go. Exactly, yeah, Kushagra. Sir, exactly. Sai ji, awesome. Kushagra, heat is directly proportional to the square of the current, resistance, and absolutely, fantastic. I mean, you guys are all behaving like stars. Can we have a star shower? Where's the star shower? Where's the star shower? Oh yes. No, let's try something new. Wait. Happy New Year. No. Let's go with yes, star shower. Because you guys are all stars. समझ रहे हो? Like that. Awesome. Absolutely fantastic job, people. Exactly correct. We know that Joule's law, according to Joule's law of heating, that is H is equal to I square RT. As simple as that. But explain it a little, because it's a 3-mark question. You can mention that heat produced in a circuit is directly proportional to the square of the current. Write it in statement as well as write the mathematical expression. Heat is directly proportional to the resistance, and heat is directly proportional to the time for which the current is flowing through the conductor. So again, please be a little descriptive in nature. It's a 3-mark question, so one line for each would actually do the trick, and also mention the mathematical expression as well. So again, this way the teacher also knows that you are very clear about this, and they don't have to actually go through the answers and go through all the trouble. All right, 7th question, people. Before we go to the 7th question, how are you guys feeling right now? All good? Yeah, all awesome. Confidence good? All super awesome? Yes. Give me a oh yeah in the chat box if you guys are all feeling excellent and are super confident right now. And all the people in this thing, all good people, give me yes. Yeah, all good. Awesome. That is the spirit of the channel. Well done, well done. All right, now before we go to the next question, do not forget to hit the subscribe button, like the video. With that said, let's go on to the next question. The 7th question on your screens. Here it is. 2 wires, A and B, are of equal length and have equal resistance. If the resistivity of A is more than that of B, which wire is thicker and why is it thicker? Fantastic question. Honestly, I really love this question. Again, it's very straightforward, but it can get a little confusing for all those who do not pay enough attention to the question itself. So let's go, people. Let's go. Arey, why are you guys so scared of English, da? Why are you guys so scared of English? English is supposed to be like, a breeze. It's supposed to be super easy. All right, Yashi, Paka, B, A, Sarah, all right. Avishta, A, Paka, A is thicker, 100%. I'll log the answer. B or A? B, Yashi, Paka, confidence. Look at Yashi, she's like, B is a Paka. Yes, I. Oh, is it? Alright. You get it? Paka. V is thicker. Paka. 100%. Alright. Now, I'll just tell you the mathematical expression, guys. Think about it for a second. We know that resistance is equal to rho into L by A. Alright. So, let's say that the resistance for A, that is the wire A, is rho A, which is the resistivity of A, into L divided by A. And RB, which is the resistance of B, is rho into B into L by A. Now, you have to find out which one is thicker. Alright, so let's say that I divide RA by RB here. Now, both of them have the same resistance. So, RA is equal to RB here. The length of A and B is also equal. All you have to find out is which one is, and they have equal resistance, they have equal length. You have to find out if the resistivity of BA is more, which one is actually thicker in nature. Now, here's the thing, guys. If you substitute the values over here, so you'll get it as rho into A into L divided by A whole divided by rho into B into A by L. So all you have to do is take A to the other side. So LL gets cancelled. Now we know that resistivity of A is more than that of B. Now here these two are equal. So I can say that rho A by rho B is equal to the, is, okay, you can keep it as it is. Sorry for that. My bad. We'll just leave it as it is. One sec, guys. One sec. Mathematically, I'm just trying to prove it mathematically over here. So you can just write it as RA by RB is equal to rho A into AB, that is area of B, divided by rho B into area of A. Now here, since these both are equal, I can take one to the other side. So I can write it as rho A or rho B by rho A is equal to AB by AA. Right? AB, 1 second. It'll be equal. So this is what you need to write it as, guys. In other words, people, since the resistivity of A is greater, the area of A also has to be greater in order for it to have equal resistance. In simple words, A will have more resistance. That's all. In simple words, A will have more resistance. But mathematically speaking, you'll have to write all these equations. All right. Mathematically, if you're asked to prove it, this is what you're supposed to do. So here again, guys, just remember the fact that these two are equal. So I can just take it as 1 because it both gets it gets divided. So all you have to do is take rho to the other side, or take A to the other side, area to the other side, or resistivity to the other side. But you'll get the answer as A is thicker. All right. So that is the answer. Got it? Clear? All that for this. All that you can directly write it, but then again, guys, it's a 3-mark question, so you can't directly say that A is thicker. Alright, it doesn't make sense. You'd only get 1 mark for that. So mathematical expression is also important. So please make a note of this one. The mathematical expression. So here you see this. So rho B is directly proportional to area of B, and rho, that is resistivity of A, is directly proportional to area of A, which means that more is the resistivity of A, more has to be the area in order for you to get equal resistance. Alright, okay, 8th question, people. We are almost towards the end. I won't take much of your time. Here's another one, a very simple numerical. The question is, a torch bulb is rated at 2.5 volt and 720 milliampere. Calculate its power, its resistance, and its energy consumed if the bulb is lit for 4 hours a day. Alright, very simple question. I'll just write on the given data, but I want you people to put it down in the chat box. Voltage is given as 2.5 volt. The current is given as 750 milliampere. Find out the power of this torch bulb. Let's go. Came in pre-boards. Awesome, huh? Awesome, Anushka. Again, like I told you, all these questions are very, very important. Awesome. Now, the most common mistakes, the mistake that you guys might end up doing over here is that, people, if you look at the current given, current is 750 milliampere. It is not given in amperes. So first thing that you need to do is divide this by 1000, which would give you the current value is 0.750 amperes. This is the first step you need to do, because milli is nothing but 10 to the power minus 3. You need to perform this first. Before doing anything else, this is the first and foremost thing you need to do, because that is going to set the precedence for the next whatever you do. Otherwise, you'll end up making all these silly mistakes. Units are very important in physics. So if you guys end up making those mistakes, then you'll end up getting the whole thing wrong. Alright, so that's it. What is the power? Power is a simple formula. Power is equal to voltage into current. Substitute the values. 2.5 into 0.750. How much will you get, people? Absolutely. It's going to be what? 0.187. Simple. 0.187 watts. That's it. Absolutely. All right. Is it 87? No, it's going to be 87. 1.87. Sorry, my bad. Not 0.187. It's going to be 1.87. 1.875 watts. Yes. Is it 0. It's not 0. It's going to be 1.8 because it's 2.5 into 0.725. No. Mathematics. I've become an expert now. All right. Now, for resistance, how do you calculate the resistance? How do? Like, bacha questions and all you're asking. Like, it's like, how do I do this? Fireworks for such easy questions. I hope these questions appear in your boards also, because it becomes very easy for you guys to score marks. It's like such straightforward and easy questions. Alright, let's go. What is it? Ohm's law. Exactly. We know that resistance is equal to voltage by current. Substitute the values over here. That's all. Voltage is 2.5 volts and current is how much? It's going to be 0.750. How much will you get in the chat box, people? What is the answer? You will get it as how much? 2.5 divided by 0.75 is how much? You will get it as 3.33 ohms. Yeah, correct? Yes. Simple, macha. That's all. Okay, last one. What is the energy consumed? Again, another easy question. The bulb is run for 4 hours a day. If it's run for 4 hours a day, what will be the energy consumed then? Pacha questions and all. What is this? Come on, put it down in the chat box, boys and girls. What is going to be the energy consumed if the bulb is lit for 4 hours a day? Come on, I know you know this. Exactly, boys and girls. Energy is equal to power into time. Put it down in the chat box. 1.875 into 4. How much will you get? you will get how much da? How much? Proper South Indian accent. How much will you get it as? How much? How much? Quickly, chat box. How much? So what you can do is, people, this will be in terms of watt hour. So if you want to convert to joules, you can do that. So you can multiply this into 60 into 60. If you want to convert into joules, you can absolutely do that. Otherwise, you can do one thing, divide this by 1000 to convert to kilowatt hour. You can do that. Either you convert that to kilowatt hour or kilowatt hour, you make it to kilowatt hour, or you can convert it to joules. So it's going to be 4 into 60 into 60 to convert into seconds. So you'll get it as something around 27,000 joules, I guess. 27,000 joules. Yes? 27,000 joules? Yeah? Correct? Pakka? That's all. Alright. So that, my friends, is the end of the eighth question. Congratulations. Fantastic job. Fantastic. Fantabulous. I believe that is the right answer. Yes, it is. Yes, it is. So 27,000 joules would be the energy in terms of joules. Now, again, if you want to find in terms of kilowatt hour, that is also perfectly fine. So what you have to do is divide this by 1000 to convert it to kilowatt, and then multiply that with 4. That will also give you the exact same answer. All right. Okay, guys. With that said, let's move on to the 8th question. Very difficult question now. Trust me, you would have never seen a question which is as difficult, as trembling, as scary as this question. All right. Even Conjuring 2 or Annabelle will fall short in front of this question. That's how scary and threatening this question is. The question is, write one application of each of the following. First one is right hand thumb rule. Second one is Fleming's left hand rule. Third is Fleming's right hand rule. Let's go, people. So difficult. So difficult. My God. All right, for the first one, right hand thumb rule. What is the application of right hand thumb rule now? Exactly, to find the magnetic field. To find the magnetic field of a straight current carrying conductor. My God. So difficult. Straight. How do you spell straight? Straight current carrying conductor. Yes, current carrying conductor. Congratulations, my boys and girls. Such a difficult question. You guys managed to answer it. All right, next one. Fleming's left hand rule. What is the application of Fleming's left hand rule? Yes, sorry, Simran Jeche, what's up? Oh, exactly. To find the direction of current or direction of force on a current carrying conductor placed in a magnetic field. In other words, Lorentz force. Oh, so difficult. Lorentz force. Amazing. I'm not going to explain it because my handwriting is horrible. For some reason, my board is all choppy. All right, next one. Fleming's right hand rule. Where do you use Fleming's right hand rule? Exactly, to find out the direction of the induced current. And save me from all these. All right, so that's the answer. Such a difficult question. Mention that also if you want. Mention the electric motor part for Fleming's left hand rule. Mention electric generator for Fleming's right hand rule, that is electromagnetic induction, or electric generator, mention that as well. And over here you can mention the for straight current carrying conductor. That's all. Such a difficult question. All right, people. So with that said, let's move on to the last question. But once again, people, for being an amazing crowd. Fantastic. All right, let's go on to the last set of questions of 4 markers. We're going to end with this particular question, a 4-mark question, a very important one. This is massive, but then it's actually very simple. The question is, calculate the resistance of 1 kilometer long copper wire of radius 1 millimeter having a resistivity of 1.72 into 10 to the power of minus 8 ohm meter. And the second part of the question is, draw a schematic diagram of a circuit consisting of a battery of 4 cells of 2 volts each, connected to a key, an ammeter, and 2 resistors, 2 ohms and 3 ohms respectively, in series, and a voltmeter which is connected across the 3 ohm resistor in order to find the potential difference. Let's go, people. Let's start with the first part of the question. I don't have much space to write, so I'm just gonna create a new slide over here. One second, let me just duplicate the slide, and I'm just gonna reduce the size of this one a little so that I can see the question. All right, so here we go, people. You need to calculate the resistance of this wire. Okay, let's write on the given data first. So the length of the wire is given as 1 kilometer. Fantastic. The radius of the wire is given as 1 millimeter. The resistivity of this wire is given as 1.72 into 10 to the power of minus 8 ohm meter. Now, people, find out what is the resistance of this wire. A fantastic, easy peasy question. So let's go for this one, guys. Let's go. Exactly. The only thing that you need to do over here, the only thing that you need to remember is the fact that you need to convert the units. That is the only mistake that you need to correct yourself with. Once you do that, everything is straightforward. Everything is going to be easy. So let's start with the first one. Length is given as 1 kilometer. So please convert that to meters. So that's basically how much? 10 to the power 3 meters or 1000 meters, because 1 kilometer is equal to 1000 meters. All right. Now for the second part, they've given the radius as 1 millimeter. So if I have to convert it to meters again, what will be the conversion like, people? In the chat box. Let's go. Let's go. Sir, आपका पेट सही है. Yeah, Priyaji. All good now. How did you know that? How did you guys know? Is it out yet? Is the trailer out yet? I don't think so, but it is not out yet, no? Hey, how did you guys know about that? Huh? The trailer is not out yet, no? Oh, is it Aryan? I'll talk. Acres, sir. How do you guys know that? All right, anyways. Acres, sir. All right, yeah. But how did... When did he say that? When did he say that? When did he come? When did he say that? Array, that's not fair. I was the one who was supposed to say it. What is this? Huh? I'll tell you. I'm not going to say anything. Now I'm okay. I'm perfectly fine now. But it's going to be... I know a secret. He roasted me yesterday. Oh, is it? All right. He's a small kid, so I'm going to let him go now. Like small little cute kid he is. So I'm just going to let him go. If it was someone else, I would have roasted them back. But Abhishek sir is like a small little cute kid with a novel face. Already life has done so much for him. So I'm just going to let him go now. It's okay. You know, ja Abhishek, ja. Ji le apni zindagi. It's okay. Let him. It's okay. You know, sometimes in life, no, you just have to, forgive and forget. That's all. All right. Anyways, moving on. Let's do this one quickly, guys. All right. Resistance is given as 1 millimeter. So I would ask you to convert this also to meters. So that's going to be 10 to the power minus 3 meters. So that is basically the conversion. Now, people, write down the formula next. Resistance is equal to rho into L by A. Substitute the values here. But before you substitute the values, the radius is what is given over here. You need to find out the area. How will you find out the area? A is equal to what? Pi r square. Substitute the value here. So it's going to be 3.14, which is nothing but pi, into radius is given as 10 to the power minus 3. I don't know, my pen is all choppy. 10 to the power minus 3, the whole square, which is going to be equal to 3.14 into 10 to the power of minus 6. My pen is all choppy. Guys, just give me a second. I'm going to refresh my page. My pen is very, very choppy. I'll just refresh the page. 1 second. Hold on for 1 second now. All right. Thank you for that. Sorry for that, because there's a lot of, and I'm not able to write clearly. There's a lot of, it's becoming very, very choppy. All right, now I hope it's fine. All right, so anyways, 3.14 into 10 to the power minus 6 is what you have. Substitute the values over here. Now, resistivity is given as 1.72 into 10 to the power of minus 8. Absolutely. Length is given as 10 to the power of 3 whole divided by 3.14 into 10 to the power of minus 6. So what you can do is simplify this, take 10 to the power 6 to the numerator. So you'll get it as 1.72 into 10 to the power of minus 8. So 6 plus 3 is going to be 9. So it's going to be plus 9 whole divided by 3.14, which is going to be equal to 1.72 into 10 divided by 3.14. This is going to be equal to what? 17.2 divided by 3.14, which when you simplify, you will get the answer as 5.5 ohms. All right. So that is the answer. Got it? All right, people. So that is the answer for this question. Absolutely, Udaiji. Absolutely. So it's going to be 17.2 divided by 3.14. If you want to multiply and divide by 100, that'll be absolutely fine. So it's going to be 1720 divided by 317. Simplify it further, and you'll get the answer as 5.5 ohms. All right, so that's all for today, people. That is all I had in store for you guys. Now, before we end today's session, once again, people, Drona Reloaded is here for all those students who are still looking for a plan to revise the entire syllabus. Drona Reloaded is for you guys. It's an absolutely fantastic option for everyone who is still looking for a revision plan. We're getting the entire Drona course for just 990 rupees for the entire, until the end of your exams, for all 6 subjects. Complete revision would be done over here. You're going to have a fantastic time over here. You'll enjoy and at the same time do your revisions along with it, right? The courses have started from 18th of April, so it's not too late. You've missed out a couple of days, couple of sessions. You'll be getting the recordings of that, so you can go through the entire thing. You'll have interactive sessions, study material, test series, tips and tricks, everything and anything. And the best part is it'll be taught by these 6 amazing gladiators. We have Amrit sir, Anuva ma'am, Ankara ma'am, Abhishek sir, Amit sir. All of these amazing gladiators would be the ones teaching you. You're going to have a blast with that. Now, for all those students who are going to 11th standard and you want to start your preparations for JEE or NEET right away, that is also covered. So don't worry about that as well. The entire 2-year course of your 11th standard, 12th standard, 10th standard revision, along with that JEE and NEET preparation, all of this would be covered for just 15,000 rupees. If you use my coupon code on top of this one, so if you click on buy now and click on buy now for the whole 2 years, if you click on it, you will get another 1,500 rupees discount, which means that what you're paying for the next 2 years of your life with JEE preparation would be just 13,500 rupees. That's all. So it's going to be around 6,000 rupees per year, which is a very, very affordable price, which is going to be basically less than 600 rupees a month. Less than 600 rupees a month. Because I'll tell you people, again, I'm going to tell you this, that in my 10th standard, about 12 years ago, I had to pay around 500 rupees per subject for tuitions, and you're going to be paying less than that for your entire JEE preparation. That is just a massive, massive, massive deal. So the choice is yours, but I would request you to actually look into it, because you have an amazing opportunity to start your preparations right now to help you clear your JEE and NEET. Because this year alone, people, we have more than 1,400 people who are into JEE, who have actually cleared their JEE and who are going to be into IITs this particular year, and about 1,100 plus students have actually cleared their NEET and who are going to be the future doctors, right? So we have produced amazing set of results. We have some super awesome track records. We have been doing it for several years from now, and we can assure you that you would also be in a good position by the end of those 2 years. Because along with all of these people, we are also giving you this Vedantu's improvement promise, which basically states that if you don't get the result, the desired result, you can actually claim for the money back. All right. So the choice is yours. I would say, if I were you, I would have jumped at this opportunity, because you're getting to prepare for JEE and NEET for just 13,500. That is just fabulous. All right. But anyways, it's you and it's your decision. Now the link, see, if you are still confused and if you want to know more about this, you can see a scroll bar at the bottom. You'll see a WhatsApp number there. All you have to do is go to the description of this video. You'll find the message as well. Type your name. My name is so-and-so, and I'm in this particular grade right now, and I want to join the family. Let's say you're in 10th standard. I am in 10th standard right now, and I want to join the family of 11th and 12th or JEE, and mention that I am texting after seeing Anoop sir's session, and you'd be getting a call back to explain in detail what exactly is AI Life and what are the benefits that you're getting out of it. All right. So the choice is yours. I'll catch you guys in the next session. I hope you enjoyed it. That's all from my side, people. If you have anything that you would like to add, anything that you want to know, please let me know. Preksha, if you want to join the Drona course, all you have to do is go to the description of this video. You'll find Drona Reloaded, the very first link under Avail All Exciting Vedantu courses. Click on that link. It'll take you to Drunav's page. Again, over here, all you have to do is click on buy course. It'll take you over here. All you have to do is use Google Pay, Phone Pay, whatever it is, enroll yourself in. That's all. All right. So that's all, people. That's all from my side. Thanks a lot for joining today's session. I hope you enjoyed it. I hope this session was helpful. If you guys want more such sessions, let me know in the comment section so that, if you guys want it, or if you want to focus more on your English right now and you want more sessions of English, let us know that also in the comment section. I'll catch you guys in the next session. I'll be reading all of your comments. Catch you guys in the next one, people. Until the next time we meet, this is Anoop signing off. Let's once again end with, what should we end with today? Well, let's end with, what should we do? Let's go with confetti shots. So thank you for being a fantastic crowd. I'll catch you guys in the next one. Take care, people. So we're going to use pi. You can use that, Sarah. Absolutely. You can use 22/7. Absolutely. If you're confused about 3.14, you can go with 22/7. Absolutely. There's nothing wrong in it. Absolutely fine. You'll still get the same answer. There's no difference at all. All right. Okay, people. So bye for now. Take care. I'll catch you guys in the next one. Peace out, stay safe, stay as awesome as always, and all the very best of luck for your exams. Catch you guys later. Adios, bye. Peace out.